Okay, guys, we will make a start now. So, welcome everyone to our GCSE Maths session. In today's lesson, we are going to be looking at 3D trigonometry. So we've done all the trigonometry that we need to know. We've done Pythagoras, we've done SOHCAHTOA, and we've done the sine rule and the cosine rule. Today's lesson will just be a recap of all of that, and then we will be moving on to 3D Pythagoras and 3D trigonometry. We'll have a look at an example, and then we will move on to looking at some exam questions. Okay, so first of all, let's go through the starter question. So this was a slightly harder question from our last lesson. So if we have a look at what we actually did over here, so we have to work out the value of x. Okay, this is our value of x. In order to work out the value of x, remember whenever we have two triangles which are present, what you would do is you would work out the sort of intersecting triangle. You would have to work out this length, the one that I've drawn in yellow, because it's connected to the other triangle. Always work out the length which is connected to the other triangle. And then once you've worked out that length, you can use SOHCAHTOA to work out the length of the angle. So if we take a look at how we would answer this question, first of all, let's split it into two triangles. Okay, so we've got a triangle like this. Okay, where this is 10 centimeters. Okay, and this is 40 degrees, and this is 13 centimeters. And we need to work out the length of this side. That's x, because that's the side which is intersecting with both triangles. Okay, now remember, whenever we've got three sides involved in some way, it's going to be the cosine rule. Okay, remember, two sides and two angles, including x, that's going to be the sine rule. And then three sides, including x, and one angle, that's going to be the cosine rule. So in this case over here, we have three sides, including x, and we have one angle, so we're going to be using the cosine rule. Okay, so first of all, we need to label our sides. The corners are going to be labeled with capital letters, and the sides are going to be labeled with lowercase letters. And remember, the side with the x, or the angle with x, has to be labeled with A. Okay, so this is capital A because the side opposite it is lowercase a. And then the other two can be B and C in any order. So we'll label this capital B and this capital C. So the side opposite this capital B is going to be lowercase b. And then the side which is opposite this capital C is going to be lowercase c. Okay, so those are our sides labeled. Okay, now we're using the cosine rule. So let's write down our formula. It's a squared equals b squared plus c squared minus 2bc cos A. That's our formula for the cosine rule, which you will realize on the formula sheet as well. So lowercase a, what's lowercase a? Lowercase a is x. Okay, so let's replace the a with an x. So it's going to be x squared, and that's equal to b squared. What's lowercase b? Is 13. So it's going to be 13 squared plus lowercase c squared. Lowercase c is over here, which is 10. So it's going to be 10 squared minus 2. Lowercase b over here is 13. Lowercase c is over here 10. And then we've got cos A, which is 40 degrees. Okay, capital A, which is 40 degrees. Okay, now this thing that we've just worked out over here, we can type into our calculator to get what x squared is. Okay, so x squared is literally equal to everything else typed into the calculator. So we're going to type in 13 squared plus 10 squared minus 2, 13, 10, and then cos 40. Okay, and that gives us an answer of 69.8284479. Okay, and then we don't want x squared. Because we don't want x squared, we want just x. We would need to square root the other side. So we would square root our answer to get what our answer is. So we would square root that to get an answer of 8.3563 dot dot dot. Okay, so that's the length of this yellow side over here. That's the length of this yellow side. Now what we're going to do is we're going to draw out the second triangle. Okay, this second triangle I've drawn out there. And what we're going to do, we know that this is x over here. We know that this is 5 centimeters. We know that's a right angle. And we know the length of this side that we've just worked out. It's 8.36 to 2 decimal places. Now, once we know this, what we can do is it's a right angle triangle. Okay, we need to work out the length, we need to work out an angle. So there's only one thing that we can do. We have to use SOHCAHTOA. Okay, now notice in this other triangle, this wasn't a right angle triangle. This first triangle over here, this was a triangle. It was a scalene triangle. Because it was a scalene triangle, all sides which were different, we have to use the sine rule or the cosine rule. Over here, because it's a right angle triangle, it's either Pythagoras or SOHCAHTOA. Because we're working out the length of an angle, it's going to be trigonometry, it's going to be SOHCAHTOA. So let's label our sides. First of all, the hypotenuse is always going to be opposite to the right angle. So opposite the right angle, we have the hypotenuse. Opposite the angle we've been given is the opposite. And then the side which is left over is the adjacent. Now, which side do we not need at all? We don't need the hypotenuse because we don't know any information about the hypotenuse at all. Okay, so now we're going to write down SOHCAHTOA. So we've got SOH, we've got KA, and then we've got TOA. Okay, and then we can make our triangles out of SOHCAHTOA, just like that. So if we've got SOHCAHTOA, we need to choose the rule which has an O in it and an A in it because we've crossed out the H because it didn't give us any information. We had no information about that side. Okay, so we need to choose the rule that has O and A in it. This one has O and H, so it's not going to be this one. This one has A and H, so it's not going to be that one. It's going to be this one, tan. Okay, so it's going to be tan angle, which is tan x, because we don't know our angle. We're going to cover that up over here. And then we're going to be left with the opposite, which is 8.36. So we're going to have 8.36 divided by the adjacent. The adjacent is over here, which is 5 centimeters. Okay, now when we're working out the angle, we want to get rid of this tan and bring it to the other side. So we're going to inverse tan the other side. Okay, so we're going to have x equals inverse tan of 8.36 over 5. Okay, and that gives us an answer of 59.1 to 1 decimal place. Okay, which is our final answer. Okay, so that was just a bit of a recap of what we did in our last lesson, where we looked at the cosine rule. It was the hardest question from last lesson, because you had to use two triangles. You had to work out the side, which was in the middle, and then you had to use that to work out the angle, which is in the other triangle. Okay, now what we're going to quickly do before we move on to some practice on 3D Pythagoras and trigonometry is summarize what we've looked at so far. We've looked at Pythagoras' theorem, we've looked at SOHCAHTOA, we've looked at the sine rule, and then we've looked at the cosine rule. Okay, so this was lesson 1, this was lesson 2, this one was lesson 3, and this one was lesson 4, and lesson 5, which is today, is all about 3D trigonometry. Okay, so when do we use Pythagoras' theorem? Okay, so just because people normally struggle with when to use what. Okay, so normally you would use Pythagoras' theorem or SOHCAHTOA when you have a right angle triangle. Okay, so the key thing over here where you would only use these when you have a right angle triangle. So if I showed you now For example, um, we have a right angle triangle over here. Okay, we can only use Pythagoras if we have a right angle triangle and we knew two of these sides. Okay, so for example, 4 and 3. Okay, and this was x. So Pythagoras is basically, if we remember, Pythagoras' theorem was a squared plus b squared equals c squared. That's what Pythagoras' theorem was. And you would only use Pythagoras' theorem when you have a right angle triangle and when you're given two sides and you're working out the length of a third side. That's when you would use Pythagoras' theorem. It has to be a right angle triangle. Okay, it has to be a right angle triangle. You have to be given two sides and you're working out the length of the third side. And that's the formula: a squared plus b squared equals c squared, where a and b are the two shorter sides. So a and b are the shorter sides, and c is the hypotenuse. Okay, so that's when you use Pythagoras' theorem. Right angle triangle, formula is a squared plus b squared equals c squared. You must be given the length of two sides and you're working out the length of the unknown side. Okay, so that's step one. That's lesson one. We looked at Pythagoras' theorem. Now in the lesson two that we had, that was all about SOHCAHTOA. Okay, so lesson two was all about SOHCAHTOA. Okay, or in other words, this is simple trigonometry. Okay, and this again, you have to have a right angle triangle for this type of trigonometry. It has to be a right angle triangle. And this time, what you will be given, there are two possibilities. You will be either given two sides and one unknown angle, or you will be given one side, one angle, and then one unknown side. So those are the possibilities that you could be given. Okay, and normally you would know that it's a trigonometry SOHCAHTOA question if you're not given the if you're given an angle, because Pythagoras' theorem, no angles are involved. Okay, in SOHCAHTOA there are angles involved. You will normally be given an angle that you would have to use either two sides and one unknown angle, or one side, one angle, and one unknown side. Okay, and SOHCAHTOA, we would write it out like this. We would have SOHCAHTOA, just like that. And then we would make our triangles out of it, just like that. And then once we've got our triangles, we know what to work out. We cover up wherever we don't know. For example, if we don't know sine, we would cover up sine. Then we would have opposite divided by hypotenuse. If we didn't know a, we would cover up a. We would have cos divided or multiplied by hypotenuse. If we didn't know a, we would cover up a and we would have opposite divided by tan. Okay, so that was trigonometry. And labeling the sides, the hypotenuse is always opposite to the right angle. You have your hypotenuse, which is the longest side in the triangle. The angle that you've been given, opposite it will be the opposite, and then the side which is left over is the adjacent. That's how you would label your triangles. Okay, so that was second lesson, SOHCAHTOA. Okay, which is your simple trigonometry. Okay, then in our third lesson, we moved on to the sine rule. Okay, so if I do over here, so the sine rule And the sine rule applies to, so this is just higher. So yeah, people who are sitting higher papers, these two are for foundation. The Sokoto and Pythagoras is trigonometry as well as higher, but this is strictly only higher. So the sine rule, we saw that it works for triangles which are scalene. Okay, so it works for scalene triangles. Okay, it works for scalene triangles. The way that you label your triangle is you label the corners with capital letters, for example, A, B, and C, and then you label the side which is opposite to the corner in the lowercase letter. So opposite capital A will be lowercase a, opposite capital B will be lowercase b, and opposite capital C will be lowercase c. That's how you would label your triangle. And then the formula for the sine rule was A over sine A equals B over sine B equals C over sine C. And we realized that once we've sort of labeled our triangle, we can cross out one of these letters. So we're only using two of those letters in the question. But again, you can watch the recording on YouTube if you would like a recap on that. Okay, so that's the sine rule. And the sine rule works when you have two sides and two angles, including x, including whatever x is, um, or yeah, it's normally two sides and two angles that you have including x. Okay, and then the cosine rule, okay, which is our most recent lesson, the cosine rule, okay, which is again only higher. When we looked at the cosine rule, we saw that again it works for scalene triangles, such as this. You would label your triangle in the same way, capital A, capital B, and capital C. Opposited lowercase a, opposite this lowercase b, and then opposite this you would have lowercase c. Okay, it works for scalene triangles again. Okay, the formula for the cosine rule was a squared equals b squared plus c squared minus 2bc cos a. And then the way that we would know to use the cosine rule is the three sides plus one angle. Okay, you would have three sides and one angle, and that includes whatever x is. Okay, that's when you would use the cosine rule. Okay, so that's basically everything that we have looked at until now. Today we're going to be looking at 3D trigonometry, which is the last lesson on trigonometry. Okay, you might not get this in the first go, but I will try my best to explain it as best as I can, but you can always watch the recording if you don't understand in the first go. Okay, because this is a really grade 8 topic. Okay, but if you've smashed all these, then you're going to be able to do 3D trigonometry and Pythagoras at any time. Okay, so we're going to start off by looking at an example of 3D Pythagoras. Then I've got one for you guys to have a go at. Okay, so normally with 3D Pythagoras, what you will have is you will have a shape, a 3D shape, and you will be asked to work out the length of a side or an angle or something like that, basically. Okay, so it says the diagram shows a cuboid A, B, C, D, E, F, G, H. Okay, so we've got A, B, C, D on the bottom, E, F, G, H at the top. Okay, now the first thing is to label anything that you know from the question. Okay, so step one is going to be label anything you know from the question. Okay, so as you can see over here, we know that AE is 4 centimeters. So AE, this length over here, is 4 centimeters. So we're going to label that as 4 centimeters. We know that AD is 5 centimeters. So we know that this length over here is 5 centimeters. And we know that DC is 8 centimeters. So we know that this length over here is 8 centimeters. Okay, so we've just labeled that on our diagram. Now it says calculate the length of AG. Now, where is AG? You will have to draw this on yourself, and normally it will ask you something like this. So AG is this line over here. It's a diagonal line which runs from the corner, bottom corner, to the top right corner. That's what AG is. You're going from A to G. Okay, so as you can see, that dotted line that I've drawn is AG. Okay, so once you've labeled anything you know from the question, what you would do is you would draw the line you need to work out. So identify what you need to work out. Okay, so you're going to identify what you need to work out. So we've identified what we need to work out. This is going to be X. Okay, AG is what we need to work out. Now the third step is the trickiest step. Okay, so the third step is basically you need to make a triangle out of the line that you've drawn. Okay, so draw out a triangle from the line you've drawn. Okay, and you will get this, but if I draw it now, for example, I need to make a triangle out of the line that I've just drawn. And the way that I would do that is as follows. Okay, so what I'm going to do is I'm going to draw a line downwards. Okay, and then I'm going to draw a line from here to here. Now, can you see that is a triangle? Okay, so we had this original line over here that we need to work out. And I've literally just made a triangle out of it, a right angle triangle out of it. And that's what you have to do. You have to make yourself a right angle triangle out of the line that you need to work out. Okay, so as you can see there, I've made myself a right angled triangle. Okay, so this is our right angle over there. Okay, so I had our X. So first I labeled everything from the question. I labeled all these sides over here. And then what I did is I identified the line that I needed to work out, AG. Okay, and I labeled that as X. And then the third step is that I draw out the triangle from the line that I need to work out. So this line that I've labeled X, I use that line to draw myself a right angle triangle. So I can work out what that missing line is. Okay, now once we've drawn that right angle triangle, we can label a few other things. Okay, so we know that this length is 4 centimeters. So that means this length over here must also be 4 centimeters. Okay, so that length there must also be 4 centimeters. Okay, now the only thing we need to work out X. Okay, but in order to work out X, we need to know the bottom line. We need to know this line over here. Okay, this bottom blue line is one line that we need to work out. And we can work it out because if you see, if you look at the bottom, this part over here, this part over here, this is a right angle triangle as well. That's a right angle triangle at the bottom as well. So if I draw that with a different color, we can see that from here to here to here, at the bottom, you've got a right angle triangle. Okay, so we can work out what this line is basically. We can work out what that line is because we know that this is 5, this is 8. So if we draw the bottom triangle first, we know that the bottom triangle is a right angle triangle. Okay, we know that it's a right angle triangle. We've got the right angle over there. And we know that one side is 8 centimeters and the other side is 5 centimeters. So we can use Pythagoras to work out what this length is over here. Okay, so it would just be a squared plus b squared equals c squared. We know that a is that, b is this, and c would be this. We know that a is 8, so it's 8 squared plus 5 squared, and that's equal to c squared. 64 plus 25 equals c squared. And then 64 plus 25 gives you 89. So 89 is equal to c squared, but we want to work out just c, so we're going to square root the other side. Okay, so c is equal to the square root of 89. Okay, so this length over here is root 89. Now we know that length, we can work out what x is over here. Okay, and the reason why is because we have a right angle triangle. Okay, so we have a triangle like this. We know that this is 4 centimeters, as you can see over here. And we know that the bottom thing that we just worked out is root 89. Okay, the bottom thing that we just worked out is root 89. We need to work out what this side is. That's x. Okay, so we use Pythagoras again. So we have a squared plus b squared equals c squared. Okay, we know that a is going to be the two shorter sides, a and b, and then c is going to be the longer side, which is opposite to the right angle. Okay, so a is 4, so it's going to be 4 squared, plus b, which is root 89 squared, and that's equal to c squared. Okay, 16 plus 89 equals c squared, and then 16 plus 89 gives you an answer of 105, and that's equal to c squared. Therefore, c equals the square root of 105, which gives you 10.25 to 2 decimal places, but it says 3 significant figures, so it's going to be 10.3 to 3 significant figures. Okay, so that's what our answer would be there. Okay, so just to go over this again, if you don't understand it, please let me know in the Q&A. But I will go over this one more time before I give you guys an example to have a go at yourself. So step 1 is going to be label everything you know about the question. So on that 3D shape, you need to label what AE is, AD, and DC is. Okay, now once you've labeled everything from the question, you then need to identify what you need to work out. So over here it says calculate the length of AG. So we're just going to draw out A to G, the dotted line, because that's the line we need to work out. Then you're going to use that line to make a triangle. Okay, you're going to use that line to make yourself a triangle. Okay, so this unknown line, we had X over here. We've made ourselves a right angle triangle by drawing a line downwards and then across to make ourselves the right angle triangle. So we've drawn out the triangle. Now, once we've drawn out the triangle, we know that if this is 4 centimeters, we can label this as 4 centimeters as well because it's a cuboid. And then we need to work out this bottom line over here of this triangle where we got root 89. And the way that we can do that, we know this side and we know this side, so we can use Pythagoras because it's a right angle triangle to work out the length of this long side at the bottom. And that gave us root 89 by using Pythagoras' theorem. And then what we did was, because we knew the base, root 89, and we knew the height, which was 4 centimeters, we could use Pythagoras again to work out the length of x over there. A squared plus b squared equals c squared. Okay. If you guys are those of you who are in year 9, this you won't be covering this yet. You will be covering this in year 10 towards the end of year 10. But again, we've sort of done all of trigonometry, and you will be, so if you're doing higher, which I did send a message, if you're planning on sitting higher papers, this will be difficult for you right now but you will be covering this, so it will still be useful to sit in this and learn how much you can from these lessons. Okay, if you guys have any questions on this, let me know. So ultimately, all you're doing over here is you're trying to make yourself a triangle and use Pythagoras to work out the length of any sides in that triangle. Okay, so here's a question for you guys to have a go at. Have a go at it and let me know what you get in the Q&A. If you're struggling, don't worry. I will go through this one after I've given everyone an opportunity to have a go at it. But same things. Label your sides. Label your sides A, B, E, A, E, and AG. Make yourself a triangle by looking at this side which you don't know, and then use Pythagoras to work out any missing lengths um, that you need to work out what x is. Okay, I'm just going to give you guys one more minute and then I'll go through the answers. Okay, I'm going to go through the answers now. Okay, so we're given a cuboid. We know that AB is 5 centimeters. So this length over here, A to B, is 5 centimeters. Okay, and we know that AE is 6 centimeters. So AE is this A to E. AE is 6 centimeters. And we know that AG is 12 centimeters. Okay, so if we go across, we know that A to G, that dotted line that I've drawn, is 12 centimeters. Okay, so that's 12 centimeters. We need to work out the length of AD. Okay, so AD is going from A to D. This length that I've drawn over there is the length we need to work out. That's going to be our x. Okay, so we need to make ourselves a triangle out of this. Now, in order to work out AD, the normal, every time this you will create the same triangle, most likely it will be a triangle which it goes like this. So if I draw it out in a different color, so normally it would be a triangle like this. So you would normally go from one side to the other side like that. Then you would go down like this, and then you would make yourself a triangle like that. Okay, so that's normally the triangle that you would use over over here. That green that I've drawn over here is the triangle, the right angle triangle that you would use. Okay, now we know that AG is 12 centimeters. We know that this is 6 centimeters. So this over here is also going to be 6 centimeters. Okay, and we need to work out this length over here. That's our X over there. And we know that this length over here is going to be the same as this length, which is 5 centimeters. Okay, so if we look at how we're going to work out X, we can see that this is a right angle triangle. Okay, we can see that we have a right angle triangle which is being produced. We have our right angle triangle. We know that this is 5 centimeters. This is X that we need to work out. And we can work out what A to C is. Okay, we can work out what A to C is. This is A to C. And we can work out what A to C is because we know what A to G is, which is 12 centimeters, and we know what G to C is because we have another right angle triangle there. Okay, so we're going to use this right angle triangle first. 12 centimeters, okay? And then we have 6 centimeters, okay? We need to work out this length, and this length is the same as this length. Okay, so we can use Pythagoras' theorem over here to work out what x is. A squared plus b squared equals c squared. We know that this is going to be the longest side, so that's c, and then this is a and b in any order. Okay, so we know it's a squared plus b squared equals c squared. So we know that a is 6 plus b, which is x, and that's equal to c, which is 12 squared. 6 squared is 36 plus x squared equals 144. If we rearrange, we get x squared equals 144, subtract 36 because we're going to take 36 from both sides. Okay, so x squared equals 144, subtract 36, which is 108. So we get that x equals the square root of 108. Okay, so the square root of 108 gives you 10.4 to 1 decimal place. Okay, so that's what this side over here x is. And x is the same as AC because AC is this side and that's the side that we've just worked out. Okay, that's the side that we've just worked out, and we can use that to work out ADC. So we can work out AD over there, which is the unknown length. Okay, so we know that AD is 10.4. So we'll just pop that there, 10.4. And what we're going to do is we are going to use that to work out what x is. So again, Pythagoras, a squared plus b squared equals c squared. A is going to be 5, b is going to be x, and c is going to be 10.4. So it's going to be 5 squared plus x squared equals 10.4 squared. 25 plus x squared equals 10.4 squared, which is 108. And then x squared is 108 subtract 25, which gives you 83. Therefore, x is equal to the square root of 83. Okay, which gives you 9.11 to 3 significant figures. Okay, so we got 9.11 there. Okay, so well done for everyone that got that. If you didn't get that, don't worry. It's the key concept over here. This will take practice. It won't you won't get it without practice. But ultimately, if you rewatch the recording again, you should be able to grasp it. So again, always make this triangle. The triangle that we had in the center, always make that triangle. And then you can use that triangle to work out what you actually need to work out, the unknown x. Okay. So now what we're going to do is we're going to look at a trigonometry example, and it's literally the exact same thing, but you're going to be using SOHCAHTOA and maybe Pythagoras in some questions. Okay, so I'm going to go through this example. Again, list everything that you know about the question. AE is 4 centimeters. So AE over here, this is 4 centimeters. Okay, AD is 5 centimeters. So AD is 5 centimeters over here, and DC is 8 centimeters. Okay, so DC over here, this is 8 centimeters. Okay, it says calculate the size of angle ECA. Okay, now ECA, where is that? Okay, so if we draw that out, this time we're going to draw a triangle ourselves. So E to C to A. That's what we're going to draw. So E to C is this to A. It's that. That's the triangle that we're going to be using. So ECA is literally going from E over here, starting at E, going to C over here, and then going to A over here. Starting off at E, then moving to C, then moving to A. And then this is a right angle over here. Okay, you know that's a right angle. We need to calculate angle ECA, so it's the middle letter. You need to calculate this angle over here. Okay, so in order to calculate an angle, remember when we're using SOHCAHTOA, what we looked at the start, when we're using SOHCAHTOA, you will need to know two sides and one missing angle. You will normally be involved with two sides and one missing angle, or you will be given one side, one missing angle, one angle, and then one missing side. So over here in this case, if we look at this example over here, we've got ourselves a right angle triangle. Okay, we need to work out this missing angle over here, that's x. We know this side is 4 centimeters. We need to know another side. Okay, and the way that we can do that is we can work out what this side over here is. Okay, this side over here, we can work out what that side is because we're given 5 over here and 8 over here. This is right angled as well. So we can use Pythagoras to work out the black line that I've drawn. So we've got the right angle triangle over here. We're going to have 5 at the bottom. We're going to have 8 over here. And this is x. That's what we need to work out. That's the side, which is this black side over here, that we're going to work out. So again, 3 sides, 1 unknown. We can use Pythagoras. A squared plus b squared equals c squared. A is over here, B is over here, and then C is over here. So we're going to have 8 squared plus 5 squared equals C squared. 8 squared is 64 plus 25, and that's equal to C squared. 64 plus 25 gives you 89. 89 is equal to C squared. So therefore C is going to be equal to the square root of 89. Okay, so this is root 89. Now we know two sides, we know this one and this one, we can work out what angle x is. So I'm going to draw that triangle, the red triangle, once again. Okay, so we're going to have our triangle. We know that this is x, we know that this is 4 centimeters, and we know that this, which we've just worked out, is root 89. This is a right angle triangle, so let's label our sides. Opposite right angle is our hypotenuse. Opposite the angle that we've been given is the opposite, and then the side which is left over is the adjacent. Okay, so once we've got that, as you can see over here, we don't need the hypotenuse at all because we're given no information about it. Again, it's lesson 2 from SOHCAHTOA. And then what we're going to be doing is we're going to write our SOHCAHTOA like this. We're going to draw out our triangles. Okay, and we need to use the one that has an O in it and an A in it. This one has O and H, not going to be this one. This one has A and H, not going to be this one. It's going to be this one because this has O and A in it. Okay, and we need to work out the angle. So we're going to cover the tan up because we need to work out the angle. We know that tan x equals the opposite divided by the adjacent. Opposite is 4, so it's going to be 4 divided by the adjacent, which is root 89. Okay, and we don't want, we want x by itself, so let's get rid of this tan. So we need to do the opposite of tan. So x is therefore equal to the tan inverse of 4 over root 89. Okay, and that's what we type into our calculator. Okay, and that gets you, it says to 3 significant figures, that gets you an answer of 22.97690,332. If we round that to 3 significant figures, 9 rounds up, so it's just going to be 23.0 degrees to 3 significant figures. Okay, In terms of trigonometry, these questions that we are looking at in a higher paper is the hardest questions that you can get. Okay, in a GCSE Maths higher paper is the hardest question that you can get. If you didn't quite understand it to the sort of until you've mastered it, is basically you just need to go over the recording to this and try answering the questions yourself, and then you will be fine with this topic. Okay, but this is the hardest trigonometry question that you can get. Okay, so again, it was literally the same as the Pythagoras one. You're making a triangle from the center of the cuboid. So if I was to write down, says, simply label what the question gives you, plus identify missing sides, which you need to work out. And then once you've done that, construct yourself a triangle. And it's normally going to be a triangle that is like this, that goes through the center of the cuboid. As you can see, we made like a diagonal triangle. We've gone from here to here through the cuboid. Okay, we've made ourselves a triangle through the cuboid. Over here, we also made ourselves a triangle through the cuboid. Okay, same thing over here. Once we've done that, then we can look at sort of what other information are we given. So we knew that this was 4 centimeters, this was x over here. We didn't know the bottom side, but we could have worked that out from the question. The bottom side was √89 because we can use 5 centimeters and 8 centimeters. Because remember, if you have a rectangle and you split the rectangle like that, you will form yourself two right angle triangles. Okay, that's why if we split our bottom rectangle diagonally, we will form ourselves two right angle triangles. And whenever we have right angle triangles, we can use SOHCAHTOA or we can use Pythagoras' theorem. So over here, we were given two sides. We needed to work out the length of another side. And because of that, we were able to use Pythagoras' theorem.